Okay, this is my video performance test. We're gonna go ahead and start off with our graph, north, south, west, and east. We got our first vector and our second vector. Our first vector is gonna be our boat vector. It's 70 degrees west of south. And we got this right here. Our inside angle is gonna be 20 degrees because 20 plus 70 is 90 degrees, and each quadrant makes up for 90 degrees. We're gonna bring it down from our x-axis. This is our right angle, and every time it's opposite of the right angle, it's our hypotenuse, and we know our boat's going 35 miles per hour. And we got this, we got our wind vector, which is 40 degrees east of south, which looks like this. This is gonna be our 40 degrees. Our inside angle is going to be 50 degrees, and we're gonna bring that down. Go ahead and focus that in for you guys. Okay, bring that down. Our right angle, and our hypotenuse is gonna be 8 miles per hour since it's opposite of the right angle. So we're gonna go ahead and bring these down. So we got our right angles, we got our inside degrees. Okay, we got our hypotenuse. Okay, so opposite of the degree is gonna be opposite. Opposite of degree is gonna be opposite. We got our h, and then we gotta find our adjacent, which I'll label as a. So what we do now, we do cosine. Since cosine is adjacent over hypotenuse, we're trying to find the adjacent, which is x. So we'll go ahead and do this. Cos 20 degrees equals x over 35. Cos 50 degrees equals x over 8. So cos 20 is equal to 0.94. We times that by 35, and x would end up equaling 33, which is our adjacent. So we'll label that. Cos 50 is 0.64 times 8, which is equal to x equals 5. So we got our x. We come down, we get our, now we're going to use sine to find our opposite, because sine is actually opposite over hypotenuse, and our opposite is actually y. So we're going to be doing the same thing, except that it's equal to y over 35, which our hypotenuse is, and goes same thing for this wind vector here. So we'll go ahead and do sine 20 degrees equals y over 35. We'll do the same thing over here. Sine 50 degrees equals y over 8. So our sine 20 is equal to 0.34 times 35 equals x equals 12. Sine 50 is 0.64 times 8, which is equal to y. Oh, sorry about that. I labeled that as x. It's supposed to be y. Y equals 6. So we know our opposite for our wind vector is going to be 6. We know our opposite for our boat vector is going to be 12. And so what we do now is we got our x and our y's for each of the vectors. So what we do now, we look at our graph. So our x for this side is 33, and that's obviously going negative. So this is going to be a negative 33 for this vector, for our x. And then our y is going down 12. It's also going to be negative 12. Our vector for this side is going to be 5, which is going positive, comma, negative 6, which is going down. And so we add these together. When we add these together, we get negative 28 minus negative 18. And so what we do now is a squared plus b squared equals c squared. So we do 28 squared plus 18 squared equals c squared. We get 784 plus 324 equals 1108. But we don't just leave it here. We actually square root this, and we get square root 1108, and it equals to 33. So the speed of our new vector is going to be 33 miles per hour. Okay. And so what we do now is we go ahead and make a new graph, since we got a new vector. And so we know our speed is 33 miles per hour. It's going this way. And 28 is going to be our x. So we got our triangle right here, 28 right here, 18 right here. We go ahead and use tangent -1. So we got tangent -1, 18 over 28. this should be our new triangle, and our magnitude is 33, and our speed is 33 miles per hour, and that's the end of the problem.